McDonald's has this Monopoly game where they advertise that 1 in 4 wins. 1 out of 4, that's a win rate of 25%. Say you actually played this game 530 times and you won 112 times. What is your win rate? 112 out of 530, that's a win rate of about 21%. Is that too low? Is something shady going on here? Is McDonald's lying about the win rate? There's two possible explanations here for why you won only 21% of the time. And here's McDonald's explanation. McDonald's is going to say this. We're not lying, the win rate is actually 25%. You got 21% because of just regular randomness of the game. When someone plays our game, sometimes they'll win more than 25%, sometimes they'll win less than 25%. That's just regular randomness of the game. It's like the situation where when someone's flipping a coin 10 times. In theory, you should get 5 heads and 5 tails. But when you actually flip a coin 10 times, are you always going to get 5 heads and 5 tails? No, right? Because of regular randomness, sometimes you get more than 5 heads, sometimes you get less than 5 heads. Nothing shady going on here. This is just regular randomness of the game. That's McDonald's explanation. What is your explanation? Your explanation would be, no. 21% is too low. It's too low to be caused by just regular randomness of the game. We think we're getting 21% because McDonald's, you are lying. You're lying about the win rate. You're falsely advertising the win rate because we think you have it set up to win less than 25%. How do we decide between these two explanations? Which one is more correct? Well, we're going to do what's called a hypothesis test. First page here is just formulas that I'll need for this lecture, so let me skip this and come back to this when we actually need it. Example 1. McDonald's says in their advertising that 1 in 4 instantly win in their McDonald's Monopoly game. You and your friends played the game 530 times and won 112 times. You and your friends think that McDonald's is falsely advertising and that the win rate is actually less than 25%. Can you conclude that the win rate is less than 25%? Use the alpha equals 0.05 level of significance. This is the same situation that we were talking about in the introduction. So McDonald's has this Monopoly game, and this game has millions and millions of game pieces. And what McDonald's is saying is that if you look at all those pieces, 25% of them are going to be winners. Now the question is, from our sample of just 530 game pieces, do we have enough evidence to conclude that McDonald's is lying? So do we have enough evidence to say that if we were to look at all those millions and millions of game pieces, that the win rate is actually less than 25%? So this is touching on the same thing that we've been talking about throughout this class. From our small sample of just 530, can we say something about the entire population? Can we say something about all those millions and millions of game pieces? When we talked about confidence intervals in the last unit, remember there was the mean situation and the proportion situation. Same thing here. For hypothesis tests, there will be the mean situation and the proportion situation. Question is, how do you tell the difference? If you see the words mean and standard deviation in the question, it's going to be a mean situation. If you don't see the words mean and standard deviation anywhere in the question, it's going to be a proportion situation. So if we go back to this question, we don't see the words mean and standard deviation anywhere in the question. So this is going to be a proportion question. And just like for confidence intervals, for proportions, we're going to be working with Z's. For means, we're going to be working with T's. So for proportions, we'll be working with Z's. Now, every hypothesis test starts off with a null and alternative hypothesis. Okay? The null hypothesis is going to be denoted H0. And the alternative hypothesis is going to be denoted H1. And let me start off with the alternative hypothesis. So the alternative hypothesis usually is going to come from the question. So the question here is, can you conclude that the win rate is less than 25%? So what we're going to do is we're going to translate that into symbols. So you're going to start either with a P for proportion or a mu, which is the symbol for mean. So because we are in the proportion situation, we're going to start off with a P. Okay? Can you conclude the win rate, so win rate or win percent, same thing as proportion. Can you conclude that the proportion is less than 25%? Okay? The symbol is either going to be a less than symbol, a greater than symbol, or a not equal symbol. This one is asking, can you conclude that the win rate is less? So this will be less. and then 25%. And then anytime we're working with percents, we always convert to a decimal. So 25% as a decimal is 0.25. So can you conclude that the win rate or proportion, can you conclude that the proportion is less than 25%? So H1 here is proportion less than 25%. H0 will be exactly the same as your H1 except with an equals in the middle. Okay, so H0 is going to be proportion equals 0.25. Okay, let me write that down. The null hypothesis will always have an equals in the middle. And for H1, we have a less than here because it says less than here. Now, what is this H0, H1? So H0 and H1 are the two competing explanations that we talked about in the introduction. H0 is McDonald's explanation. McDonald's is saying, we're not lying, the proportion is actually equal to 0.25. H1 is your explanation, right? You're saying McDonald's is lying and that the win rate is actually less than 25%. And the goal of a hypothesis test is to decide which of those explanations is the more correct or more probable explanation for what's going on in the situation. Okay, so I'm going to skip over part B and come back to it at the end of this question and skip to part C. Part C says find the Z or T test statistic. So because we're talking about proportions, we're going to be looking for the Z. If this were a mean question, you will be looking for a T here. And these refer to the formulas on the front page. So let's go to the front page and talk about those formulas. The two formulas on the front page are formulas that you'll be using to find the test statistic. Which is part C of the process. The first one with the Z, that's for the proportion situation. The second one with the T, that's for the mean situation. And the box at the bottom, these are the R commands that you'll need later on. The first row, P norm, Q norm, we've seen those before. That's going to be for Z's. And remember, Z's go with proportions. And then the second row, PT, QT, that's going to be for the T's. And T's go with means. Back to part C. This is a proportion question, and we said for proportions, we're going to be finding Z. So we'll be using the first formula on the formula sheet. If this were a mean question, you would be using the second formula. So the first formula has a P hat, a P0, and an N. So what are these letters? So we're looking for, well, we need to find a P hat, a P0, and an N. Okay, so P hat is the proportion from our sample. So our sample, we played the game 530 times and we won 112 times. That's our sample. So we took a sample of 530 and out of those 530, we won 112 times. So our P hat, our proportion from the sample, would be 112 out of 530. And let me enter this into a calculator and then round to 3 decimal places. So 112 over 530. 0.211. P0. So P0 is the proportion that you use in H0. Okay, so in H0, our proportion was 0.25. So P0 is 0.25. And in N, N always stands for sample size. So what is our total sample size? We played the game 530 times, so that's our total sample size. Okay, so we have everything we need to enter it into the calculator. So I'm going to enter P hat, P0, Pn into this Z formula. Okay, so this is I'm starting with a fraction. Up top, it's P hat minus P0, so it's going to be 0.211 minus 0.25. Okay, on the bottom, it's a big square root, so I'm going to click square root, and then I'm going to click the fraction button to make sure that that fraction is inside the square root. Then up top, inside the square root, it's going to be P0, 1 minus P0, so P0 is 0.25, 1 minus 0.25, over 530. Okay, make sure what you see in the calculator looks exactly like this formula. And once it's exactly like this formula, you can hit enter. And we get a z of negative 2.073, so round to 3 decimal places. And that is our test statistic. Part D, find a p-value. So to find a p-value, we're going to draw either the z distribution or the t distribution. Now when I draw it, it both looks the same. So it's basically going to be the normal distribution picture. And these pictures will either be shaded to the left, shaded to the right, or two tails. If it's less than, it will be shaded to the left. If it's greater than, it's going to be shaded to the right. If it's not equals, it will be two tails. Okay, this is a less than, this will be shaded to the left. So we're going to shade on the left side. And then you're going to put your answer from part C on the picture. So our test statistic from part C is z equals negative 2.073. And our job here is to find a p-value. So p-value, the p stands for probability. Probability, remember, you should think area. So what we're looking for here is the area of this shaded region. Okay? So this is a z to area type question. For a z to area question, so z to area, for the z situation, it's going to be p norm. Now, if this were a mean question, you will be talking about t's, and you will be doing pt. So for us, we're going to be doing p norm. The z. So the z here is negative 2.073. Okay, so in R, p norm, negative 2.073. Okay, and I get 0.019 rounded to 3 decimal places. Now the way p norm works is you feed it a z, it spits out a left area. So this 0.019 is a left area. Now sometimes you have to do something to it before you get a final answer, sometimes you don't. So this is the left area, and the question you need to ask yourself is, are you looking for a left area? Yes, right, this is an area to the left, so we are looking for this shaded area, which is a left area. So that's our answer. Okay, the p-value is just going to be 0.019. What is the meaning of this p-value that we just found? So this p-value is saying, assuming that H0 is true, so assuming that McDonald's is telling the truth and that the proportion is actually 0.25, then what happened to us winning only 112 times out of 530? And remember, we thought that was too low. So what happened to us winning only 112 times out of 530? This p-value is the probability of that happening from just regular randomness of the game. And remember, that was McDonald's explanation. McDonald's was saying that they weren't lying and that we got such a low win rate from just regular randomness of the game. And the p-value and the probability is 0.019, which as a percent is 1.9%. So that's a really low number, right? So if McDonald's is telling the truth and it were just regular randomness of the game, then what happened to us is something that's really, really rare. And the idea here is that if we get a p-value that is really low, then that's an indication that it's probably not just from regular randomness of the game. And that a better explanation is that H0 is actually false. In other words, McDonald's is lying. This is similar to a situation where you're flipping a coin 20 times. Say you flip a coin 20 times and it comes up heads, 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 all 20 heads. Could that happen from just regular randomness of flipping coins? Yes, it's possible, right? When you flip a coin 20 times, it could come up all heads. That is possible. But that is extremely rare. In other words, it has a very low probability, a very low p-value. So low that as you're flipping a coin, at some point, you're going to get suspicious, right? Because that's so rare to see all these heads. You're going to get suspicious and think to yourself, maybe something's wrong with the coin. Maybe the coin is not a fair coin. And that's what we're talking about here. If the p-value is really low, then what we're witnessing is probably not due to just regular randomness of the situation. And that a better explanation is probably that H0 is wrong or H0 is false. Now the question is, when is a p-value considered to be low? So low that we're going to say this is probably not due to just regular randomness, and that a better explanation is that H0 is false. And that brings me to part E. We're going to decide whether to reject H0 or don't reject H0. And the bar for what's considered to be low is the alpha. Use the alpha equals 0.05 level of significance. So if the p-value is less than that alpha, then it's considered to be low. Okay, if it's not less than, it's not considered to be low. So we're going to check whether our p-value is less than the alpha. Our p-value was 0.019. The alpha is 0.05. And the question is the p-value less than the alpha? So currently, the p-value has 3 decimal places and the alpha has 2. So my recommendation is to add on 0 so that both have the same number of decimal places. So I'm going to add on a 0 to this 0.5, just because it makes it easier for me to compare. So we're comparing 0.19 versus 0.50. So basically 19 versus 50. Is 0.19 less than 0.50? Yes. Okay. So if it's less, then that means our p-value is considered to be low. So low enough for us to say that H0 is false. In other words, we're going to reject H0. So if the p-value is less than alpha, we're going to reject H0. If the p-value is not less than alpha, we're going to don't reject H0. Part F. So part F is our final concluding sentence. And this is the sentence that I want you to write. Basically, this sentence is asking whether we can conclude that H1 is true. Okay? So we're going to start off by saying you're going to state your significance level. So our significance level is alpha equals 0.05. So at alpha equals 0.05, level of significance there, and then you're going to write either is or is not. So if we are able to reject H0, then yes, we can say that H1 is true. Okay, so if you reject H0, then there is enough evidence to conclude that, and then you're going to state H1. So H1 is saying that the proportion is less than 0.25. But usually I go back to the sentence here. Can you conclude that the win rate is less than 25%? So because we did reject, there is enough evidence to conclude that the win rate is less than 25%. So once again, if you reject H0, then there is enough evidence. If you did not reject H0, then there is not enough evidence. I should mention here that the only 2 outcomes of a hypothesis test is either reject H0 or don't reject H0. You will never say anything else. Even though in English, you may think that the opposite of reject should be accept, but you will never say accept H0. So this is similar to in a court of law, you're either found guilty or not guilty. Not guilty is not the same thing as saying innocent. And here's an example. Many years ago, I got a speeding ticket. And I took the speeding ticket to court. Now, On the day of the court hearing, the cop who wrote me the speeding ticket didn't show up. So I was found not guilty. Now, not guilty is not the same thing as innocent, because I was speeding. Just I didn't think I was speeding by a lot. So I was found not guilty, not because I was innocent. I was found not guilty because cop didn't show up, so there wasn't enough evidence to prove that I was guilty. And same thing with hypothesis tests. Either you reject or you don't reject. And you don't reject, all that means is that there wasn't enough evidence for you to reject H0. So those are the only two outcomes that of a hypothesis test. Either you reject H0 or you don't reject H0. Nothing else. Let's now go back to part B that we skipped. Find a critical value and sketch the rejection region. So there's two approaches to hypothesis testing. Part C and D together that we just did is called the p-value approach. So we started by finding the test statistic, and then we used that test statistic to find a p-value. Right? That's why it's called a p-value approach. And then we use the p-value to help us decide whether to reject or don't reject H0. So there's another approach for deciding whether to reject or don't reject, and that's called the critical value approach. So for part B, we're going to draw the same picture that we did in part D, so either the z distribution or the t distribution, and when I draw it, it looks the same. And this picture will either be shaded to the left, shaded to the right, or two tails. If it's a less than, it's going to be shaded left. If it's a greater than, it's going to be shaded to the right. If it's not equals, it will be two tails. This is less than, so it's going to be shaded to the left. Okay, so you should have the same picture for parts B and D. For this picture, the shaded area is the alpha, and our alpha is 0.05. And our goal in this step is to either find a z star or a t star. Okay, so if we're talking about proportions, it's going to be a z star. If we're talking about means, it's going to be a t star. So this is proportions. So we're looking for this z star that has an area of 0.05 to the left. Okay, so this is an area to z question. So we look back at our commands in R. Area to z, for the z situation, we're going to do a Q norm, left area. Okay, so we're going to feed it the left area of the picture. 0.05, is that a left area? Yes, so 0.05 is the shaded area, which is a left area right now, so we don't have to do anything to it. So we're just going to enter it into the Q norm. Okay, so switch to R. We're going to do Q norm 0.05. Okay, and that gives us a z. So that negative 1.645, round to 3 decimal places again. And that's a z star. Okay, and that's the critical value. And this picture is a picture of the rejection region. So how does this help me decide whether to reject or don't reject? Okay, so in part B, you find the critical value, and then you would do part C and find a test statistic. If this test statistic is in the shaded region, that's called a rejection region. So if this test statistic is in the shaded region, we reject. If it's not in the shaded region, you don't reject. Okay? So the question is this z, negative 2.073, is that in the shaded region or is it in the unshaded region? This z star, which we found, is negative 1.645, so negative 1 something. The question is negative 2.073, would that be to the left or to the right of negative 1.645? This is negative 1.645. Negative 2 something on a number line would be to the left, which would put it in the shaded region. So this z is in the shaded region. That tells me that I should reject, okay, which we did. So this gives us another way to double check our work for part E, reject or don't reject. So the critical value approach should give you the same answer as the p-value approach. Okay, so that just gives you another way to check. Now the question is, why does the critical value approach work? So if you notice, we don't actually need the exact p-value, right? All we really need is to know whether the p-value is less than alpha, right? So you don't actually need to know the exact p-value. All we care about is whether the p-value is less than the alpha. And so what we're doing here is we're finding the z that has exactly 0.05 to left, which means if you're in the rejection region, right, if you're in this shaded region, and you look at the area to the left, that would be a smaller area. So for sure, that area is going to be less than 0.05. Okay, so that means that if you were to find the exact p-value, it's for sure going to be less than 0.05, which is why we reject. Before we move on, let me point out one thing. Part C and D together, where we're looking for the p-value, this is something that we've already done when we talked about the normal distribution. So we're looking for a p-value at the end of the day. So p-value is a probability, and probability, you should think area. Okay, so part C and D is really an x to area type question that we were talking about when we talked about the normal distribution. And when we talked about the normal distribution, for an x to area type question, the first thing we did was we used the z-score formula. And then after we get a z-score, we use p-norm. And so what I wanted to point out is in part C, where we find the z or t test statistic, we're using one of these formulas on the front page, either the z formula or the t formula. And what I want to point out here is that these two formulas are really just z-score formulas. So both of these are of the form x minus the mean over a standard deviation. So we look at the z formula, so that's for the proportion situation. In the proportion situation, the mean you're supposed to use is the population proportion. The standard deviation is the big square root formula. Okay, this formula is p hat, which is our x, minus the population proportion, which is the mean, divided by big square root formula, which is the standard deviation we're supposed to use for proportions. The t formula looks even more like the z-score formula. So x minus the mean, divided by standard deviation over square root of n. And standard deviation over square root of n is exactly the standard deviation we're supposed to use for the mean situation. So these formulas are really z-score formula. And part C, you're really just finding the z-score. After you have the z-score, we do a p-norm. So C and D together is really just an x to area type question that we did when we talked about the normal distribution. Example 2. In 2010, the mean length of YouTube ads was 40 seconds. A recent sample of 50 YouTube ads had a mean length of 41.8 seconds, with standard deviation 5.7 seconds. Can you conclude that the mean length of YouTube ads has increased? In other words, can you conclude that the mean length of current YouTube ads is more than 40 seconds? Use the alpha equals 0.01 level of significance. So the question is, from our sample of just 50 YouTube ads, can we say that if we were to look at all the YouTube ads, that the mean is more than 40? So part A, state the null and alternative hypotheses. So this is our H0, H1. And before I do that, the first thing I actually need to check is whether this is a mean situation or a proportion situation. So when you read the question, if it mentions mean and standard deviation, it's going to be a mean situation. If you don't see the words mean or standard deviation anywhere, it's going to be a proportion. So when I read this, I saw the word mean everywhere. Okay, so this is definitely going to be a mean question. And then just to remind myself, for means, we're going to be using t's. And for proportions, we use z's. Okay, so back to H0, H1. I usually start with H1. So H1 usually is going to come from your question. Can you conclude that the mean length is more than 40? So we're going to translate that into symbols. Now, the symbol that you're going to start with is either going to be P for proportion or mu for mean. Since we're talking about means, the symbol is going to be mu. And then it will either be a less than, greater than, or not equals. The question here is saying can you conclude that the mean is more than 40? So more, that means greater than, and then it says more than 40, so greater than 40. Okay, and then for means, we don't convert to decimals or anything. Okay, that's H1. H0 will be exactly the same, except with an equals in the middle. So this will be mean equals 40. Part B, find the critical value and sketch the rejection region. Okay, so we're going to draw the normal distribution or the t-distribution, which looks the same when I draw it. It's either going to be shaded left, shaded right, or two tails. If it's a less than, it will be less, or if it's a less than, it will be shaded to the left. If it's greater than, it will be shaded to the right. If it's not equals, it will be two tails. This one is a greater than, so this will be shaded to the right. Okay, and for part B, the shaded area is the alpha. So our alpha here is 0.01. Okay, that's the shaded area to the right. And your job is to find either the z star or the t star. Because we're talking about means, we're looking for a t star here. Okay, if this were a proportion question, you'll be looking for a z star. So this is basically a area to t question. So area to t for the t situation is going to be qt left area df. Okay, so we're going to do qt left area df. So for this picture, is 0.01 the left area? No. 0.01 is this shaded area, and this shaded area is to the right. So what I need to plug into qt is the left area, which is this unshaded part on the left side. So how do you find this unshaded part on the left side? So anytime you have a probability or an area, to get the other side, you do a 1 minus. Okay, so we're going to do 1 minus 0.01. Okay. 0.99. Okay, that's the unshaded part to the left, and that's what I need to plug into qt. So 0.0 or 0.99, comma, df. So qt has two things you have to enter. Left area, df. df is degrees of freedom. It's 1 less than the sample size. So what is the sample size? A recent sample of 50 YouTube ads, so 1 less will be 49. Okay, so we're going to do qt 0.9949. Okay, this gives me 2.405. And this is the t star that I'm looking for. Okay, if this were a proportion question, this would be a z star, and you will be doing q norm here, and q norm would only have 0.99. Q norm does not have a degrees of freedom. Part C. Find the z or t test statistic. So we're talking about means here, t's. So I should be using the t formula for test statistic. And the t formula is this one. So this t formula has a x bar, a mu 0, an s, and an n. Okay, so let me write all those down. There's an x bar, a mu 0, an s, and an n. Okay. X bar. So x bar is the mean from our sample. So what is the mean from the sample? Recent sample of 50 YouTube ads had a mean length of 41.8. Okay. X bar, which is the mean from the sample of 50 ads, was 41.8. So x bar is 41.8. Mu 0, right, the 0, is the mean that we use in H0. Okay, so in H0, the mean we used was 40. S stands for standard deviation. So what is the standard deviation? Standard deviation, 5.7. N is the sample size. So what is our sample size here? Recent sample of 50 YouTube ads. It's going to be 50. Okay, so I have everything I need now to enter it into the formula. So we're going to enter it into this T formula. So in decimals here, I'm going to start with fraction. Up top, x bar minus mu 0. That's going to be 41.8 minus 40. On the bottom, it's another fraction. And then for the bottom fraction up top, it's an S, which is 5.7. And then over square root of n, square root of 50. Square root 50. Okay, make sure what you see on decimals looks exactly like the T formula here. And once it does, you can hit enter. And I get 2.233. So round it to 3 decimal places. Okay, this is a T. 2.233. Okay, so that's our test statistic. So right now, we can actually use this critical value approach to predict whether we should be rejecting or don't reject. Okay, so let's do that here. So this T is exactly 2.405. The question is this test statistic, 2.233, would that be in the rejection or in the shaded area, or would it be in the unshaded area? Okay, this boundary here is 2.405. Where is 2.233? So 2.233 on a number line would be to the left of 2.405, right? 233 would be to the left of 405, which would put it in the unshaded region. Okay, if you're in the shaded region, you reject. If you're in the unshaded region, you don't reject. So I expect that when we get to part E, I should get a don't reject. Okay, so just remember that. Part D, find a p-value. So p-value, we're going to draw the same picture as in part B. Okay, still it will be shaded to the right because we're talking about greater than here. If it were less than, it would be to the left. If it were not equals, it will be two tails. Okay, this will be, because it's greater than, this will be to the right. Put your test statistic that you found in part C on a picture. So our test statistic is 2.233. And your job here is to find the area of that shaded region. Okay, this is a T to area question. So for a T to area question, T to area, for the T situation, it will be a PT T df. Okay, so we're going to do PT. The T, which is the 2.233, comma, the df, the degrees of freedom, that's one less than our sample size. Our sample size was 50, so one less would be 49. Okay, so in R, we'll do PT, 2.233, comma, 49. 0.985. Now, most of the time, when you find a p-value, it should be a pretty small number. 985, that's a big number, right? Which means this is not our answer. And the reason why it's not our answer is because p-norm and pt, it spits out a left area. So this 0.985 is a left area. Okay, so on this picture, the left area would be this white part, right? It's 0.985. But that's not what we're looking for. We're looking for the shaded area, which is the area to the right. So 0.985 is the unshaded part. To get the other side, do a 1 minus. So because we're looking for the area to the right, we have this one extra step of doing a 1 minus. Okay, so our final answer is going to be 1 minus 0.985. Okay, 1 minus 0.015. Okay, we are expecting a small p-value most of the time, and 0.015 is small. Okay, so that's our p-value for part D. Now, this was for a mean situation. If this were a proportion situation, right, we would have z here, we would have a z here. For z's, you will be doing p-norm, and you would just feed it to z. P-norm does not have a degrees of freedom. And then for the same reason, you would have to do 1 minus the answer you get from the p-norm. Part E, reject or don't reject. Okay, so we're going to look at the p-value and check if it's less than the alpha. Our p-value is 0.015. What's our alpha? Our alpha was 0.01. Okay, and like I said, I usually add zeros so that they both have the same number of decimal places. This one has 3. Let me add on a 0 here. And the question is the p-value less than the alpha? So 0.15 versus 0.10, which is basically 15 versus 10. So is the p-value less than alpha? It's not less, right? So 15 is not less than 10. So if it's not less, you don't reject. Okay, which is what we predicted would happen when we did the critical value approach. Right? This test statistic was not in the shaded area, so we don't reject. Part F, our final sentence. Okay, so the sentence is asking, can we conclude that H1 is true? So we're going to say at state our significance level, so at alpha equals, it was 0.01. Level of significance, there you're going to write is or is not. Okay, if you reject, it's is enough evidence. If you don't reject, there is not enough evidence to conclude that. And then we're just going to translate this H1. And what I usually do is I go back to the question here. Can you conclude that the mean length of current YouTube ads is more than 40 seconds? So mean length of current YouTube ads is more than 40. More than 40 seconds. There's one more thing I want to mention before we move on. For questions that are shaded to the right, like example 2 here, just from the picture, we expect the critical value and the test statistic to be positive, and they are. So, which means if you didn't get a positive answer for the critical value, what probably happened was you forgot to do the 1 minus before plugging it into QT or QNorm. Okay, let's go back and look at example 1. Example 1 was an example of a shaded to the left picture. And so based on the picture, we expect the critical value and the test statistic to be negative, and they were. So if you don't get a negative answer for the critical value, what probably happened there was you did a 1 minus when you shouldn't have. Okay, so use the picture to help you predict whether it should be positive or negative, and then use that to help check your answer. And then for part D, the p-value, for p-values, we expect small answers. So if you're getting answers like 0.9 or 0.8, big answers like that, what probably happened was either you forgot to do a 1 minus, or if you did do a 1 minus, you weren't supposed to do a 1 minus. Okay? So use that as a way to check your answer also. Example 3. A national survey reported that only 16% of college students watch the news. A researcher at CRC wants to know whether the percentage of students who watch the news at CRC differs from the percentage among college students in general. She surveys a simple random sample of 199 students at CRC and finds that 42 of them watch the news. Can she conclude that the proportion of students who watch the news at CRC differs from 16%? Use the alpha equals 0.03 level of significance. First thing I need to do is decide whether this is a mean question or a proportion question. So if you see the words mean and standard deviation in the question, it's going to be a mean question. If you don't see the words mean or standard deviation anywhere in the question, it's going to be a proportion question. Looking back at the question here, I don't see the words mean or standard deviation anywhere in the question. This is going to be a proportion question. And for proportions, we're going to use z's. For means, we use t's. So we'll be using z's here. Part A, state the null and alternative hypotheses. So this is the H0, H1. Okay, make sure you use the correct symbol. For proportions, we use p's. For means, we use the mu symbol. Okay, so let's read our question again. Can she conclude that the proportion of students who watch the news at CRC differs from 16%? Keyword there is the word differs. Okay, differs means not equals. So H1 is going to be proportion, not equals, 16%. Okay, convert your percents to decimals. 16% as a decimal, 0.16. Okay, that's H1. H0 is going to be the same as H1 except with an equals in the middle. So H0 always has an equals in the middle. So H0 will say P equals 0.16. Part B, find a critical value and sketch the rejection region. So we're going to draw either the Z distribution or the T distribution. If it's a less than, it will be shaded left. If it's a greater than, it will be shaded right. If it's not equals, it will be two-tailed, so the left and the right. Okay, and as always, the shaded area is the alpha. Okay, so alpha here is 0.03. Okay, that's the area of the shaded region, which is the left and right together. So left and right together is 0.03. And we're either looking for Z star or T star. Because we're talking about proportion, we're looking for Z star. And there's going to be two Z stars because this picture has a left and a right. If this were a mean question, you'll be looking for T stars here. So this is really a area to Z question. So area to Z. Area to Z for the Z situation is going to be a Q norm left area. So we're going to Q norm the left area. Now, what is the left area? It's not quite 0.03. So 0.03 is the left and the right together. So I just want the left to plug into Q norm. So if the left and right together is 0.03, if I just want the left, divide it by 2. Okay, so we're going to divide it by 2 and then plug into Q norm. Okay, so in R, not in R, in the calculator, 0.03 divided by 2. 0.015. Okay, that's just the left part, which is what I need to plug into Q norm. So Q norm 0.015. Okay, Q norm doesn't have a DF, so that's it. So in R, Q norm 0.015. Negative 2.170. Okay, from my picture, I expect two answers. So negative 2.170 is the left. The one on the right is going to be the positive version. So our answers are negative 2.170 and 2.170. Okay, these are z's, z stars. Okay, on your lab, you're going to enter it as negative 2.170, comma, 2.170. Part C. Find the z or t test statistic. We're talking about proportions here, so I'm looking for the z here. Okay, so we're going to be using the z formula. So this one has a p hat, a p0, and an n. So I'm going to write that down. Okay, p hat. P hat is the proportion from the sample. So she takes a sample of 199 students and finds that 42 of them watch the news. So from our sample, the proportion that watches the news is 42 out of 199. So 42 over 199. Okay, let's calculate that. 42 over 199. Okay, round to 3 decimal places, 0.211. P0, so P0 comes from H0, the proportion that we used there, which was 0.16. And then N is our sample size, how many people total. Our sample size was simple random sample of 199 students total, so 199. Okay, plug into the Z formula. So the Z formula is this one. Okay, so in Desmos, start off with a fraction. Up top, P hat minus P0, that's going to be 0.211 minus 0.16. Okay, on the bottom, big square root, so square root, and then click on the fraction button to make sure that that fraction is inside the square root. And then inside the square root up top is going to be P0, 1 minus P0, that's going to be 0.16, 1 minus 0.16, and then on the bottom, N, 199. Okay, make sure what you have on Desmos looks exactly like the Z formula, and then hit enter. Okay, so I get a Z of 1.962. Okay, so if this were a mean question, you'll be using the T formula. And then for part B, I don't remember if I talked about it, but if this were a mean question, you would still do the divide by 2 to find the left area. And then instead of Q norm, you'll be doing QT, 0.015 comma degrees of freedom, which would be 198 in this case. Okay, if this was a mean question. Part D, find a p-value. So you're going to draw the same picture. Not equals, this is going to be left and right, shade left and right. The term is 2 tails. Okay, put the test statistic that you found in part C on the picture. So this is 1.962, that's positive. That refers to one on the right. Okay, there should also be a left one, which as you can probably guess, it's going to be negative 1.962. And our job here is to find the shaded area. So this is a Z to area type question. So Z to area in the Z situation is a P norm Z. So we're going to do P norm Z. Now the question is, which Z do you plug in? So let's try to be smart about this. We're trying to find the shaded area, right? And the way P norm works is you feed a Z and it gives you the area to the left. So I don't want to plug in the positive z, because if I put in positive z, it's going to give me the area to the left of it, which includes this unshaded part in the middle, which I don't want, right? So plug in the negative version. So if I plug in the negative version, it will give me only the shaded part. Okay, so we're going to plug in negative 1.962. Okay, so p norm, negative 1.962. Okay, and that gives me 0.025. So rounded to 3 decimal places, 0.025. Okay, the way p norm works is it gives you the area to the left. So this is a left area. So it gives you the area to the left of the negative 1.692, which means this part is 0.025. Okay, I want the area of both together, right? So if this one is 0.025, you can probably guess that the area on the right side here is the same because it looks the same, and you will be correct. The area on the right side here is also 0.025. And if I want both areas together, you can either add those two up, or you can take one of them and multiply by 2. So I'm going to multiply by 2. So we're going to take the left one here and then multiply by 2. So 2 times 0.025. Okay, so 2 times 0.025. 0.05. And that's our p-value. Part E, reject or don't reject. So this is where you take your p-value and see if it's less than your alpha. P-value 0.05. Our alpha 0.03. And then usually I add on 0 so that they both have the same number of decimal places. You don't have to add here because they both have 2 decimal places, but if one of them has 3 decimal places, you would add on 0 so that it match. And then the question is the p-value less than alpha? So 0.50 versus 0.30. Is it less? No, it's not. So it's not less, which means this is a don't reject. Okay, just to double check my answer, let's go and do the critical value approach. So that was from the p-value approach. Critical value approach, the question is this test statistic in the shaded region or is it in the unshaded region? So from part B, we know that the boundaries here are negative 2.170 and 2.170. So where is 1.960 or 1.962, sorry? Is it in the shaded part or is it in the unshaded part? So here is 2.170. 1.962 would be slightly to the left of that, right? Because it's less, slightly to the left. Would you put it in the unshaded zone? So if you're in the unshaded area, you don't reject. If you're in the shaded area, you reject. So because 1.962 is in the unshaded part, you don't reject, which actually matches our p-value approach. So we probably are on the right track here. Part F. So we're deciding whether we can say that H1 is true. At, state your significance level. So at alpha equals, our alpha here is 0.03. Level of significance, there is or is not. Okay, because we did not reject H0, there is not enough evidence to say that H1 is true. To conclude that, and then I usually go back to the sentence here, can you conclude that the proportion of students who watch the news at CRC differs from 16%? So there is not enough evidence to conclude that the proportion of students who watch the news at CRC differs from %16. All right, so that's an introduction to hypothesis testing. Have a great day. See you guys next time.